In 7.4, we are focusing on proportions, and I want you, by the end of this lesson, to be able to identify and solve proportions with variables. So what is a proportion? A proportion is just two equal ratios. So write that down along with your target. It's just two equal ratios. That means it's a fraction equal to another fraction. So if you look in an algebra book, it might say something like A over B equals C over D. That's just an example with letters. All it is two ratios that are equal. So we've talked about this idea before, but if two ratios are equal, we can call it proportional, or they form a proportion. And to check if they are a proportion, you have two options. You have two methods that you can use. So method one would be finding a common denominator between the two ratios and then decide whether they are proportional by making them have the same denominator. So let's look at this. If I have 6/8 and I'm comparing that to 9/12 and I want to know, does this make a proportion? Are they proportional? Are the ratios equal is all I'm asking. So one way is to find a common denominator. So common denominator between 8 and 12, maybe it might help you to list out the multiples of each and find where they overlap. This is called the least common multiple. You don't have to show this, but it may help. So 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 36, and let's see if that's enough. So 12 then, 12 times 1 is 12, 12 times 2 is 24. I actually can stop there because I already see my overlap. My lowest common denominator that I can get for 8 and 12 is going to be 24. So now you can just take each fraction and figure out what to multiply by to get a denominator of 24. For 6/8, I would want to multiply 8 by 3, and whatever you do to the bottom, you must do to the top. So I'm going to multiply the top by 3 as well. 18/24. For 9/12, if I want to get a denominator of 24, I would multiply the bottom by 2, so I'd multiply the top by 2. 9 times 2 is 18. These are equal, so yes, they are proportional. So write that down. Yes, they are proportional. Your other method then would be finding the cross product. And a lot of you may have already heard of this method. One way to find out if a ratio is proportional to it or is equal to another ratio, or if these two make a proportion, would be just to cross multiply. So you only cross multiply when there's an equal sign in the center. Let's clarify that. So 8 times 9, let's check if that does equal 6 times 12. If they are equal to each other, these cross products, then the ratios are proportional. 8 times 9 is 72, and 6 times 12 is 72. So yes, they are proportional. You could write this over here as well. Why do the cross products work? I do want to make sure you guys understand that. Why are we allowed to cross multiply? Let's think about this statement, this equation. Remember, in an equation, whatever you do to one side, you must do to the other, right? As long as you do that action to both sides, it's still an equation. Let's think about this. If I wanted to get rid of a fraction, if I didn't want to have to deal with the denominator, I could multiply both sides of this equation by a number to cancel out the denominators. To cancel out this 8, I would want to multiply by 8, right? Because then I would have an 8 in the bottom and an 8 on top. So I'd multiply by 8 over 1. We saw this yesterday with 7/3 when we did conversions, cross-canceling. Well, then remember, whatever you do to one side, you would do to the other. And I'm not even going to multiply it out. I'm just going to cancel out what I cancel here. So 8 and 8 would cancel, and I'd end up with 6 equal to, I'm going to leave this as 9 times 8, and then I would have it over 12. So multiplying straight across, 9 times 8 over 12. Then, to cancel out the 12 as a denominator, you would multiply both sides by 12 over 1. And when you do this, when you multiply both sides by 12 over 1, now the 12s cancel on the right, and you're really left with 12 times 6 is equal to 9 times 8, which you see is just the cross products. So this is actually why it works. I want you to understand that. Technically, cross multiplying is a shortcut, but this is the mathematical reasoning why it works. Because whatever you do to one side in an equation, you can do to the other. Really, this is all the work you're doing in your head. So I do want to make sure that makes sense. I hope you wrote that down. If you didn't, go ahead and pause the video and jot that down in the corner of your paper just so you have an idea. So now that we've tried a couple of these, tell whether the ratios are proportional, I want you to try A and B, one each way. So do method 1 on A, method 2 on B, and then press play to check out your work with me. So go ahead and pause and try it now. So now that you've tried example 1, I said method 1 on A, which was getting a common denominator, so I have 6/15 and 4/10. I could multiply, or actually in this one, I can reduce to get a common denominator. I can get them both to be 5. So what would get 15 to become 5? Dividing by 3. And 6 to become 5? Dividing by 3 on the top. I'm sorry, not 6 to become 5, but and 6 to have the same action to it. So divide by 3, which would be 2/5. For 4/10, what would I do to 10 to get 5? Divide by 2. Whatever you do to the bottom, you do to the top. So 4 divided by 2 is 2. So are these ratios proportional? If these are equal, yes. Now you could have multiplied, if you got them to be 150, you would multiply this first fraction by 10 over 10 and the second fraction by 15 over 15. You should still see that they are proportional. This connects back to that first lesson when we talked about equivalent ratios. Remember, we can multiply or divide to get equivalent ratios. For method 2 then on B, we check the cross product. So I want to know, is 5 times 4, is that equal to 10 times 2? 5 times 4 is 20. 2 times 10 is 20. So yes, this one is also proportional. So you have two methods. You can use either one on your homework. Both methods are good practice. So to solve a proportion, we can use these methods as well, okay? Now, if you look at our two ratios, we have two ratios equal to each other, but we have something unknown. We have a variable there. So we can still use the same methods. Method 1 would be to multiply. If you think about it, look in these fractions. These are equivalent ratios. So 2/3 is what I have. I have all of those numbers, and it becomes 14 over G. Ask yourself, what did you multiply by to get 14? So look for the numbers that pair up. These both have numbers on top, so I'm starting in the numerator. 2 times what would give me 14? 7. Remember in math, whatever you do to one side, you do to the other. In these fractions, whatever we do to the top, we do to the bottom. So 3 times 7 is going to give me my answer for G. So 3 times 7 equals G then. What does G equal? 21. If you plug that in, 14 over 21, and we reduce that, to reduce it down, simplify it, we would divide by 2. Divide by 7. We can't take 2 out of 21. So divide by 7. 14 divided by 7 is 2. 21 divided by 7 is 3. So this is like a little check, okay? You don't have to show this work, but I'm just checking it out. G equals 21. So one method is to multiply. Figure out what you multiplied one side by and do it to the other side. The other method then is to find the cross product. Cross multiply here. So 6 times P equals 12 times 5. Now you may be asking, does it matter if I write it this way or this way? You tell me that answer. Does it matter? No. This is the same equation, guys, so it doesn't matter which product you put on the left and which product you put on the right, okay? So we have 6P is equal to 12 times 5. 12 times 5 is 60. Finish solving. How do I get P by itself? Divide by 6 on both sides, and I can find that P is 10. So two methods to solve proportions, cross products, or figure out what you multiplied by. I put a challenge proportion in here. If you take a look at this one, the denominator doesn't just have a variable, it has a variable with a number. So let's try this one together. This is a little beyond pre-algebra, but you will definitely see this in algebra next year. So when doing the cross product here, we would still multiply 6 times 7 is equal to, but now you have 2 times this whole thing. When you have more than one term, you need to use parentheses. So this is tricky. We would actually do 2 times, put in parentheses, y minus 3. So now, how do I finish solving this? Well, we have to get rid of those parentheses, so let's distribute that 2. 6 times 7 equals, distribute the 2 times y gives me 2y, and the 2 times a minus 3 gives me a negative 6. Simplify this, what's 6 times 7? 42 equals 2y minus 6, and now you can solve it. Now you've definitely seen this. So go ahead and add 6 to both sides. And then divide by 2. So we undo that addition and subtraction first, and then the multiplication and division. So y equals 24. Remember, you can always plug that back in to check it. So 6 over 24 minus 3 would be 6 over 21. And I want to know, is that equal to 2/7? Well, to check this, 7 times 21 gives me, 7 times 3 gives me 21, and 2 times 3 gives me 6, so yes, it does check out. Last example in our notes then is an application of how we can use this. We use proportions when we think about maps. A map of Illinois is being made to a scale of 1 inch is to 18 inches. So we have a scale. You can write this scale is a ratio, so we can write it as a ratio as a fraction, okay? 1 inch to 18 miles. If Chicago to Evanston on the map is 0.625 inches, what is the actual distance? So this 1 inch on a map coincides to 18 miles in real life. And I have a map where I have the 0.625 inches, and I want to know how many miles that is in real life. So notice how I matched up map and map on top, real and real on bottom. If I don't know something, I use a variable. So you have a proportion. We have 1 over 18 is equal to 0.625 over x. So go ahead and cross multiply to solve this. 1 times x equals 18 times 0.625. So that means x equals, let's use our calculator for this one, 18 times 0.625, or 625 thousandths. We got 11 and 1/4, or 0.25 miles. So just kind of a neat application of where proportions are seen in the world. I think you're ready for some practice.